Welcome to the session on computer system security. We assume that you have understood the prerequisite topic, namely computer networks. This will help you in better understanding of this topic. In this session, we will discuss concept of computer system security, which consists of physical security and operating system security. The need for computer system security and the different levels of computer system security. Let us see why security is important. Most of the enterprise systems today, such as banking, medical systems and missile launching system, are automated and largely controlled by software systems. Because of the increased dependency on computers to help run businesses and keep track of our personal information, entire industries have been formed around the practice of network and computer security. If the system is not protected, it may lead to malicious use of information and computer resources, which can have serious consequences like compromise critical systems and data, forgery, which can include email, text or graphical information. Security breaches can spread a negative message about the person or organization. Overall, if the systems are not secure, it will result in losses of both financial as well as reputation of the organization. In the past, we have numerous occasions when these systems have been penetrated by hackers, leading to security breaches. Keeping the cost of security breaches in mind, computer security should be one of the priorities of any business that uses IT. Let us see the objective and levels of computer system security. The primary objective of computer security includes protection of information and property from theft, corruption or natural disaster, while allowing the information and property to remain accessible and productive to its intended users. The computer security need to be implemented in the following multiple levels: application, operating system, hardware and network. Application level security. The risks associated with respect to security of an application can be breach of data privacy, wherein an unauthorized person may try to access confidential information; identity theft, which is a form of fraud or cheating of another person's identity in which someone pretends to be someone else by assuming that person's identity; unauthorized use of functionality, which typically can include malicious elevation of the privileges; lack of accountability, which is often an organizational policy requirement and directly supports non-repudiation; deterrence, fault isolation, intrusion detection and prevention. The solution for the above said risks include authentication, authorization, data privacy and integrity, and also non-repudiation. Now let us elaborate on operating system security. The risks associated can be hijacking of the entire system, unauthorized elevation of privileges, malicious program execution. The solutions to overcome these risks include user administration. For example, in Unix, the classes of users are owner, group and others. Through the user management, we can make sure only the authorized persons have the permissions to perform critical tasks. Device and file control, blocking the use of unauthorized devices like thumb drives, camera, etc., and providing classes of permission for files such as read, write, and execute. Isolation of program memory areas, making sure that users or program's memory not conflicting with other user or program memory. Protection against malicious software such as virus and worms. Hardware layer security. The risks associated can be system non-availability, which involves depriving the services of the system to the authentic users and malfunctioning of hardware. The solution for hardware security include physical security, which includes access control, wherein only specific users can enter the protected area. Example, server rooms, thereby keeping the systems secure. Backup and disaster recovery measures, keeping a backup of critical information such that if anything goes wrong, always the information can be regained. To implement hardware security, it is necessary to have a conditioned environment by efficient temperature control mechanisms and making sure that there is regulated and uninterrupted power supply. Network layer security involves all activities that organization, enterprises, and institutions undertake to protect the value and ongoing usability of assets and the integrity and continuity of operations. An effective network security strategy requires identifying threats and then choosing the most effective set of tools to combat them. Some of the risks associated with network security are denial of services, wherein the legitimate users are deprived of services. Spoofing. Describe a variety of ways in which hardware and software can be fooled. IP spoofing, for example, involves trickery that makes a message appear as if it came from an authorized IP address. Hijacking of traffic. Attacker takes control of a communication just as an airplane hijacker takes control of a flight. Solutions that are used to protect networks. Cryptography. This involves encryption and decryption of content being communicated over the network. Firewall, used to prevent unauthorized internet users from accessing private networks connected to the internet. Demilitarized zone, DMZ. DMZ configuration is used to prevent unauthorized access to local area networks within the organization. Virtual private network, VPN. Using VPN, it is possible to have secure and private communication over public internet. To summarize, dependency on computer systems necessitates to consider security as one of the major priorities. Computer system security levels include application, operating system, hardware, and network. For hands-on practice, please do the exercises provided in the lab guide under the security topic. This will help you understand the implementation aspects.